Hey there, this is the next video in my video series where I'm going to walk through some Python analysis for a recent competition I did, the Women in Data Datathon. And in this video, I'm going to be using clips from two different recording sessions. So I'm sorry if that ends up looking kind of weird. You will notice a couple of jumps back and forth, but I'm going to try to make it as smooth as possible because I actually recorded myself doing the analysis solo, and then I recorded it again when I was walking through it with my teammates from the Datathon. So that's why there's two different video sources. Again, apologies. I'm going to try to make it as smooth and as seamless as possible. There will also be a couple of points where I will show a couple of links where you can actually go and download the file for the project and the data set to use in the analysis. So you can actually walk through all of the steps in the video along with me if you're interested in doing that. So whenever those links pop up, you might just want to pause the video, go ahead and go to those links and download those resources so that you can walk along with me in the analysis. So I'm going to break this up again into little chunks so that the video is not super long and you'll be able to come back and revisit the sections that you want to. The first video in this series is going to be just kind of setting up the environment in Colab and walking through the features of the notebook, talking a little bit more about the basic functionality of Colab and kind of starting a Python project in that environment. So I hope you enjoy it and stay tuned for the next videos. I wanted to take a minute and just go over how to access the files for the video series that I'm going to be publishing. And there are a couple of different ways that you can do that. So I do have a GitHub page, which you can access by either going to github.com/Jennifer-Fowler, or I created a tiny URL for that. So you can go to tinyurl.com/gitjen, GITJEN, and that will take you to my GitHub homepage. And you'll notice that I have several repositories in here. I typically create a new repository for each of my projects. And so for the WID Datathon project, everything is in this repository. So you can click on this repository and you can actually download this whole folder very easily. So you just click on this blue code link and you say download the zip file. The other way that you can access these documents are by going to these tiny URLs that I've included in the video. So if you would like to type in tinyurl.com/widnb1, WIDNB1, that will take you to the notebook file. And from there, I would suggest that you open up a blank Google Colab document. So you can just search by going to Google Colab, click on the link, and just start a new file. So you can say new notebook here. If you really would like to learn, I would suggest that you do it this way and open up a blank notebook and copy and paste things over into the Jupyter notebook and run things as you're pasting them in, because I think that will help you learn a little bit better. But here is all the code for the notebook. And then the other link that I provided here is where you can find the actual data set that you're going to need. So what you'll do is go to that link, and the tiny URL for that is tinyurl.com/nb1data. And that is going to take you to the CSV file that's hosted in Google Drive. And from there, you should be able to download it to your local machine. And then after you download it, you will follow the instructions in the video to upload it to your session storage. And then you should be able to copy and paste the code over from the GitHub file into the Colab notebook and follow along with the video here. In Google Colab, if you start a brand new notebook, this is what it looks like. And I think it automatically defaults to this file type. So this .ipynb is a Jupyter Notebook file extension. So you can run these Jupyter Notebooks in Google Colab, but you can also download these and run them in any Python environment. I use I use Colab a lot for schoolwork and for these kind of collaborative projects. But when I'm working on like my PhD thesis and, the work that I do just for other purposes, I guess, I use my desktop Visual Studio Code, which is a free developer environment from Microsoft, and it's very robust. So you can actually open these in Visual Studio Code as well, and there's only a little bit of difference in some of the functions. Like sometimes, like in Colab, when you install a package, you use different language. You do something like this, pip install, and then the name of package. But in Visual Studio Code, you would be doing this differently. So Colab is a really good place to learn and play around because it's safe and you're not going to mess anything up on your computer and you don't have to worry about package version histories and all that kind of stuff, which can get really messy when you're working on your desktop computer. So you run into issues with you have an older version of Python and you need to use the new version of a scikit-learn package, and then you update your version of Python, and then you can't use this other like dependency package that hasn't been updated to that version of Python yet. So this is just much easier especially when you're learning to code. So when you first open it up, these are all basically the Jupyter Notebook format just means that everything is in little chunks. So that you can run things like one cell at a time, and it's way easier to debug and to learn. Instead of running in like a regular code file, you might have 300 or 400 lines of code, and then you run the whole program, and you have to like really trace back through which line where an error went wrong or something like that. So that's what's nice about the Jupyter Notebook like format. And you can use these buttons to insert code or text. And so in the project, we had some text in here, and I highly recommend to everybody to include as much text and annotation as possible, because even if you think you're going to remember something later on, or if you want it to be reproducible or share it with others, like that, you really need to practice good code annotation and stuff like that. So, and in the Explorer, over here we have our, if you use this kind of markdown language here, you can create this table of contents if you want. If you want to generate kind of like a nice report. And then you have your variables. This is like your environment pane in RStudio Desktop, where it'll show you all of the data frames and variables that you've put in the session. And then you have your file browser functionality where you can upload the CSV files and stuff. But this is emptied every time your session closes. So you have to re-upload them. There are two ways that you can upload data sets in Colab, and one of them is uploading them directly to the session storage and then linking them just with this file path. But there's another way that you can bridge it directly to the file that's in your Google Drive. I'm not going to show that right now, but I'll show that in another video later on. But there are ways to do it that way so that you don't have to upload it to your session storage every time. Okay, so this is the notebook with the Python project related to the Women in Data Datathon that I mentioned. So if you're not familiar with Google Colab, you may want to check my other video that walks over the Colab environment, but this is basically what it looks like when you have a completed notebook. I'm going to take this at a level of assuming that people watching have no prior experience with Python. So if you do have some experience, some of these may already be familiar. Some of these topics or concepts may already be familiar, but the whole mission or the whole point of me making these videos is to encourage people that may not have any experience or that are intimidated in trying to learn it. So that's the approach that I'm taking. So basically, if you open that up, what we're going to do first is upload the CSV file with this button. I guess I already did in mine. So yeah, just click on that button and find it after you download it, and then upload it to your session storage. You can copy the file path directly, so you don't have to worry about spelling and capitalization and stuff. So you can just click on those three little dots and say copy path. And then that's what you insert here in single quotation marks. So when you're working in Python, everything is going to be the main kind of operators that you're going to be dealing with are going to be equal sign, parentheses, square brackets, and single quotation marks. Column names, feature names, and file paths should all be in single quotation marks. And then you'll be using a variety of parentheses and brackets and stuff a lot. And it gets very picky about that stuff. But One thing I like about Colab is that, and our Studio Desktop and stuff, other environments do this too, but basically when you click on a parentheses, it'll show you highlighted in a box the corresponding open or closing parentheses, so you can make sure you have the right number when you get into the more complicated like functions and stuff. The first part of pretty much any coding project or any data project that you're going to be doing in R, Python, or anything like that is importing the packages and tools that you're going to be using throughout the project. We're going to import pandas. And so pandas is a really robust Python package for handling data and manipulating data. And it's commonly abbreviated as PD. So whenever you're importing your packages, you can you use the word import, and then you're going to give the name of the package. And then if you want to abbreviate it, you can say as, and then provide the abbreviation that you want to use throughout the code project. So throughout the rest of this project, I can just type PD instead of pandas, or NP instead of NumPy whenever it's time for me to call functions from these packages. If I did not use this import pandas as PD, I would have had to have typed pandas here, like pandas.read. So it's just easier. And a lot of the examples you might see online are going to have these same abbreviations that are shown here. So the second one here, like I just said, it's NumPy or NP, and that has a lot of statistical mathematical formulas and functionality. Import Seaborn as SNS, that is a visualization package. And I also import, I don't even think I use Seaborn in this project, but I put it in there just in case. And then Matplotlib PyPlot as PLT, and that is another mathematical and visualization statistical package that has a lot of functionality. It's really commonly used. So I'm going to go ahead and run the cell to get my session started and get these packages imported. And after you run a cell, you'll notice the little green check mark will pop up if everything runs properly, if it gets executed, and it'll also start a timer on there so you can remember how long ago you ran the cell. The timer here is really handy because sometimes when you're doing stuff, like when I got down here and I was doing all this data manipulation, sometimes you have to go back and rerun cells to clear things out or kind of start over. And so that helps you keep track of when you ran each cell if you need to redo anything. So next we need to pull my CSV file into the project so we can perform some manipulation on it. And just for those of you guys who are not familiar with Python, the green text here is comments that I put in there. And the way that you do that is by using the hash or pound sign. So basically you can type a hash sign, one hash sign, and anything that's on that line after that should be a different color text, like green, and the computer will not read it as a code command. I have comments in here. We're going to import the packages, upload the dataset CSV file to the session storage, which we just did using this button. So it's over here in my CSV file. So we're going to be using the pandas function read CSV to import the CSV file. And once again, just for basics, you're going to assign it a variable name of whatever you want to call it throughout the rest of your project. So for this project, we were working with World Bank data. So I just called it WBD because that's easy to type. So I'm telling it WBD equals, I'm assigning it to the CSV file that is linked here in my session storage. So with the read CSV function, all you're doing is you're going to do PD or pandas.read underscore CSV, open parentheses, and then you're going to tell it the file path of the file that you want to import, which you could have copied just now from your session storage. And you're going to put them in single quotation marks, this file path. And so it should indicate that it's a different color. And then you're going to want to make sure and close your parentheses there. So after you run the cell, now I've got this data frame in my variable pane. And it shows me the shape here. So 9,828 rows and 12 columns is how big this data frame is. Okay, so those two are done. My data set is loaded up. I've got my packages imported. I'm ready to go in terms of analysis and stuff. All right, I'm going to stop here. So at this point, we have initiated our Python environment in Google Colab and uploaded our CSV file and gone over some of the basic functionality, again, of Colab and how to complete those initial functions. We've talked about importing packages and abbreviations. This is a good stopping point before we really get into the analysis. So I'm going to cut it here. And then the next video is when we will begin the data manipulation and analysis for the WID project.